conditional probability. Let A and B be two events. The probability of A given B, so note that I'm using a vertical line segment here. Probability of A, you read this vertical line given. The probability of A given B, it means that, hey, this A depends on B, is equal to the probability of their intersection, the probability of A and B divided by probability of B. So if you want to read this, it is probability of A intersection translates into and B divided by P of B. So we first find the probability of the intersection between A and B, then we divide it by the probability of B. For example, let's go over one example to feel comfortable about this topic. Consider the following table. Here in this table, I have the gender and I have the degree. It's divided up this way. I have male 361. Let me write down the rest of it here for you. Let me list the numbers first. Okay, perfect. 361 for associate degree. And we have 581 for female. Then we have bachelor's degree, 734. And for female, it's 982. Then for master's degree, and then finally PhD. We have 292, 439, and I have 80, 84, 80, 84. So we're going to answer these questions. First of all, what is the probability? This is the question that we have. What is the probability that being male and having a bachelor's? So male and having bachelor's degree. How do we calculate this? 2, what is the probability of having a bachelor's degree? Having have the bachelor's degree. How do we calculate these two probabilities? And finally, here's a question. What is the probability of being male given that, with the condition that it's coming from the category of having bachelor's degree? How do we calculate this? So what do we have here? Question says, well, male and having bachelor. Okay, male and having bachelor. You're looking for the intersection between them. Remember, and represents the intersection. Being male and having a bachelor. Well, this is my numerator, 734. This is 734. Out of what? What is the sample space? The sample space is the total of people who participated in this survey. So the number of people who have participated in this survey, let's take a look at this. It's going to be 3553. 3553. 3,553 people participated in this survey. So you're going to write this down on the denominator, 53. What is the probability of having a bachelor? Having a bachelor, okay. So how many people have bachelor, male and female? So you're looking for the total, the sum of 734 and also 982. This goes on my numerator. 734 plus 982. But divided by what? What is the sample space? Again, out of the total population. 3,553. Okay, let's add this together. 1716 divided by 3553. Okay, now the last question is a conditional probability. We're restricting the category, conditional. So it says the probability of being male with the condition that, given that, restricted to only people with bachelor. So let us follow the definition. It says, hey, on the numerator, you're going to write down the probability of being male and having bachelor, which is this number here, this fraction here, 734 divided by 3553. And on the denominator, you're going to have the probability of people who are just having bachelor's degree, which is 1716 divided by 3553. You can simplify this by getting rid of the same denominator. So you're going to get 734 divided by 1716. So you can convert that into percentage by dividing these two and get the percent based on the question that is asked.